factorization. So prime factorization is a multiplication statement of prime factors. So it's a way of representing a number. So for example, 12 equals 2 squared times 3. So 2 and 3 are prime factors. Yes, I'm using exponents. And yes, I'm putting the factors in numerical order. Okay, so order counts. We want to use exponents. So instead of going 2 times 2 times 3, you're going to use the shortcut of exponents. All right? So that's what prime factorization is. What we're going to do is factorize it and then write it as a multiplication statement. What are some prime factors? 2, 3, 5, 7. What else? What's the next one? Take a guess. This is where you guys can shout out. Take a guess. 11. 9 would be 3 times 3, so it's not prime. Then 13. Then 17. Then 19. Now the ones that we're going to deal with the most are these ones. Okay, those are the most common you're going to see over and over again. You will only see these ones once in a while. So if you're stuck, then you want to try those. If you're not stuck, then you're going to use one of the first 4. Okay? So we're going to start with 72. And way back when, we did a factor tree. So we went, what two numbers multiply to 72? Let's go 8 and 9. Okay? So those two numbers multiply to 72. Those are factors. Are they prime? No. So 8 can break down into 2 and 4. 9 can break down into 3 and 3. Okay? We're still not prime yet, so then we'll go one step further. Now the 2 doesn't change, the 4 does. The 3s don't change, they're already prime. Okay? Now what's the prime factorization then? What does 72 equal? Okay, so you're going to use the bottom row. Go ahead, write your prime factorization. How many 2's are being multiplied?
3.
Okay, and now I'm using a multiplication dot. It's not a decimal, it's a multiplication dot. How many 3's are being multiplied? 2. Notice how you write the factors in order. I don't put the 3 at the beginning, right? Low to high. So this here is your prime factorization. Okay, 72 equals 2 cubed times 3 squared in order. Now, that's using the factor tree. You've probably done that lots. What we're going to do is introduce the factor ladder, and some of you have probably already done this. This is an even number, so we can divide by 2. Okay. How many times does 2 go into 7? 3. Okay. And there will be 1 left over, right, because that's 6. So the 1 I can put over with the 12. Okay, so the 2 and make 12. How many times does 2 go into 12? 6. Okay. Now it's an even number, so I can choose 2 again. Okay. Do the division yourself, please. So it goes in 1 time, and there'll be 1 remaining. And so instead of 6, that's now 16, so it should be 8. So you can divide by 2 again, and get 9. Then 9 is 3 and 3. Okay, so now you're prime. Okay, so again, 72 equals 2 cubed times 3 squared. Now you could have divided by 3 at the beginning. You could divide by 3 and you were in there. It doesn't matter. But because it's even, I'm going to choose 2. Okay. When you're dividing by 3, do you guys remember the rule for dividing by 3? Okay. Well, the digits will add to a number divisible by 3. Okay. So for example, 72, that would be 7 plus 2 equals 9, and 9 would be divisible by 3. Okay. Or 36, it would be 3 plus 6 equals 9, you can divide it by 3. 18, 1 plus 8 equals 9, so you can divide it by 3. So it's just a quick way to check if it's divisible by 3 or not. Okay. Remember these easy questions will be on your non-calculator section of the unit test, the non-calculator section of the final exam. Okay. They're not going to give you crazy hard ones on that section. Okay. They'll give you crazy hard ones on the calculator section. All right. And you have a calculator to help. So, okay, let's see what you can do. Write the prime factorization. So divide it. You get 44. Go ahead, finish it off. You're going to finish with 88 equals, and then a multiplication statement. Okay. And then you can do 120 as well. I'll give you a minute. Okay, who's got them? First one, 88. Eden?
3 cubed times 11.
3 cubed? Oh, sorry.
2 cubed.
Yeah, 2 cubed. Okay, 2 cubed times 11. Good. 120. I know I'm rushing some people, but Morella, did you get it?
Yeah, I got 2 cubed times.
Good. Now, you don't have to do your division in the same order as me. You'll still get the same answer if you're dividing correctly. Okay, that's kind of what I wanted to show you with B, is that you can do it in several different orders, then just list them in a proper order, going from your low 2 to your higher factor of 5. Any questions? Okay, so what we're going to do now is start combining this together to find our GCF. The GCF stands for the greatest common factor, and you've probably seen that before. And I know you've used that because you need to use that to reduce fractions. Now, if you Google this, you probably won't see GCF. You'll probably see HCF, and that's just the H stands for highest. That's more of an American term because they're not as smart of us. So they don't use the word greatest. Okay, I'm just making that up, but they do use HCF. Okay, you even see that in some textbooks. Keep in mind that the factors, or the GCF, are smaller than the starting numbers. Okay, so double check your work. The GCF should be smaller than the numbers. So let's do 15 and 21. Just kind of ignore this stuff. I'm going to just kind of go 15, 21. You can divide them both. So do a division at the same time. What number can you divide them both by? 3. So then you'd be left with 5 and 7. Can you divide 5 and 7 by the same number? Absolutely not. So your GCF equals 3. You're done. Okay, your GCF equals 3. Let's try the next one. Cross this off. Write down 52, 78. Okay, what number can you divide them both by? They're both even. Good, so divide them both by 2. All right, it's a little challenging for you. 26, I think. 39. Okay. Well, one's even, one's odd, so you can't divide them by 2. 6 plus 2 plus 6 equals 8. That's not divisible by 3, so you can't divide 26 by 3. So go through your factors. Can you divide by 5? No. Divide by 7? No. Divide by 11? No. Divide by 13? Oh, wait a second. Can you? Try it. You get 2 and 3. So you can. So now your GCF equals 2 times 13. Multiply them together. Your GCF equals 26. Okay, you should be able to write it in both formats, please. Okay, that's the best way to show your GCF. Okay. Any questions? Notice where you find your GCF, folks? We're finding it out front right there, where you're able to divide all the numbers by the same number. Okay, okay. Try 18 and 24. Go. In fact, you don't need to rewrite this. You can just start dividing right here if you want. Okay. So your GCF is 6 for the first one. Hands up if you got that. Awesome. Okay, next one's going to be a little more challenging. Go for it. I know some of you already started. Awesome. Okay, let's turn it over. So what we're going to do is look at the cousin. The cousin is LCM. It stands for lowest or least common multiple. Now multiple, they're larger than the numbers you start with. Okay, they're larger. So I'll show you that right away. So listing the multiples, you go 5, 10, 15, 20, 25, 30, 35. Wow, man, that's hard work. Okay, list the multiples of 8 and 10, please. Go. Okay, so multiples of 8, 16, 24, 32, 40, 48. 10 would be 10, 20, 30, 40, 50. Which one do they have in common? 40. Okay. So that's the one way to do it if you get stuck. Not that, but for harder numbers, it's going to be tough. So doing the prime factorization method, well, cross that off. We're just going to do our simple division one. Divide them all by the same number. We have 5, and then we get 2, 3, and 5. So GCF is 5, but the LCM makes the letter L. Okay, so the LCM equals 2 times 3 times 5 squared. Okay, then you can multiply them together. 6 times 25. And what's the value of 6 quarters? $1.50? Okay. So you can do multiplication in your head. Sometimes money helps. All right. Any questions? All right. Let's try the next one. So we want to determine the GCF and the LCM. So let's go 28, 42, 63. Divide them all by the same number. Let's divide them all by, what number would they share? It's a tough one. 2's out, 3's out, 5's out, 7? 7 work for them all? It does. So divide by 7. You're going to get 4, 6, and 9. Okay. Can you divide them all by the same number now? No. Like 4 and 6, you can divide by 2, but not the 9. 6 and 9, you can divide by 3, but not the 4. So now you can put a little GCF line. Your GCF equals 7. This is where you got to be careful. Okay, so you can continue dividing. Divide by 2, and you get 2, 3. The 9 does not get divided, you just carry it down. That's a little different. Okay, if it doesn't get divided, you just carry it down. What else can we divide by now? 3. Okay, so this becomes 2 doesn't get divided, it carries down. This becomes a 1, and this becomes a 3. So what's your LCM? 2 squared times, okay, don't forget it makes the letter L, all of them, right? So 2 squared times 3 squared times 7. We never include the 1 because it changes nothing, right? Multiplying anything by the number 1 changes nothing, so we just don't include it. Okay, and so what does this equal? 4 times 9 times 7. 4 times 63. Ooh. Calculator if you want. Actually, don't use calculator. Let's go old school, folks. Multiply them. 252. Is that right? Double check my work, please. Is that right? Awesome. Okay. So no calculator. You guys can do it. Any questions? Yep.
Okay, so for like a question, whatever, are you going to say the model values and calculators or how?
There's a non-calc section and there's a calculator section.
Okay, so it should be.
Yeah, these ones would be a non-calc, a harder one though, okay? But I mean, you can do the multiplication in your head, okay? If I'm giving you big numbers like 42 and 96, I would put that in the calculator section. In fact, I'd probably do even harder ones than that in the calculator section. Okay, it just gets a little bit longer, that's all. And then the LCM gets larger, okay? So smaller numbers, definitely no calc, okay? All right, try the next one by yourselves. Go for it. Do your division, see what you can get. Am I missing one? Second. What does it equal? What is it equal to? LCM 360. Anyone else get that? Okay. So you gotta be careful of this one. Here's your GCF. I mean, 2 times 2 and a 3. After that, it gets a little bit tricky with your divisions. This will be like the hardest type of LCM you'll find. Okay, so when you're dividing by 2 equals 1, 4 divided by 2 is 2. The 5 just carries down. It doesn't get divided. Same with the 12. Well, sorry, the 12 gets divided. Okay, then you divide by 2 again, the 5 carries down. Okay. We don't include the 1s in our LCM. Right? They're not a prime factor, they're not included. Okay. Hands up if you got that. Awesome. So what I like to do to see how well you're doing, thumbs up means you get it, you know what you're doing. Thumbs down, no idea what you're doing. In the middle is you kind of get it, but you need more practice. So thumbs up, thumbs down in the middle. Okay. All right. Okay, let's go on then. Applications. So working with fractions. So what you want to do, and you do this all the time without thinking, or you should be able to, is you want to divide by a GCF to reduce to lowest terms. Okay, so 28 and 98, divide them both by 2, get 14 and 49. Divide those by 7, get 2 and 7. So your GCF equals 14. So we divide the top by 14 and we divide the bottom by 14. That's what we're doing when we're reducing fractions. Okay, so you just quickly find the GCF. And often you do this in your head when you have simple numbers without even thinking about it. Okay, so you're dividing this one, you can get 2 over 7, I believe. Okay. Now, of course, that bottom division is a harder one. You'd probably do more time on that if you did it in your head. Okay. Next one, when you add or subtract, you need to find a common denominator. You hear that over and over. You want to be able to do this because you're going to really need to be able to do this. Your common denominator is actually your LCM, lowest common multiple. 5, 12, and 3. Anyone see it? No? Well, so find your LCM, 5, 12, and 3. Divide by 3, this carries down, this becomes a 4, this becomes a 1. You divide by 2 if you will, 5, 2, and a 1. So your LCM equals 2 squared times 3 times 5. Okay. What is that? 2 squared is 4 times 3 times 5, 12 times 5, 60. So each fraction you're going to make out of 60. Okay. And so then you change your numerators. So times this one by 12, you get 36 over 60. Times this one by 5, and you get 25 over 60. Times this one by 20, and you get 140 over 60. Okay? Now you can add or subtract the top numbers. So application right there using your LCM. Okay. Any questions? Okay. Next one. Read the word problem, underline the important information. Go. Okay, so first of all, she's cutting the material. So you think she's going to have a number larger or smaller than what she started with? Smaller. Okay. Now she's cutting it, but she wants to know what's the largest size of these smaller pieces. So that's GCF. So what you're doing is you're finding your GCF. There's one material that's 12 by 36, the other 6 by 42. So we got 6, 12, 36, 42. Find your GCF. Divide by 2. And then divide by what? 3? So what's your GCF? Okay. Now try and answer the question. Okay. So reread it, try and answer the question with this very simple sentence. So the largest square is 6 inches by 6 inches. Okay. Okay. So she has this material, cuts into squares, but she wants to do the largest square. So what's the GCF? C. Read C, underlying the important information. Go. Analyze the question. They're stacking pails. So one is going to be stacked at 24 at a time, so 24, 24, 24, going higher. The next one will be 40 at a time, 40, 40, 40. So we're looking for a number that's smaller than 24 and 40? Or we're looking for a number that's larger? Larger, okay. But they want to know when they're the same height using the least amount of pails. So we're looking for the LCM. Okay. So we have 24 and 40. Find your LCM. Okay. Okay, so for 24 and 40, so the LCM is going to be 2 cubed times 3 times 5. The GCF is 2 cubed. Okay. So then we can go and figure out the LCM actual number. 8 times 5 is 40, times 3 is 120. Okay. So at 120 pails, the stacks are the same height. Writing the sentence just helps you reflect on the question to make sure you answered it properly and didn't make some kind of understanding error. Okay? Just a little double check. Any questions? Okay, now what they like to do is sometimes you have to work backwards. So if I gave you the GCF is 2 cubed and the LCM is 2 cubed times 3 times 5, right? So say I said the GCF was 8, you would then convert it to 2 cubed. If I said that the LCM is 120, you'd convert it to its prime factorization. Now what's important to know here is that the GCF is equally shared, right? They both get 2 cubed. So the GCF is equally shared. But the LCM okay, so the 3 can go up top and the 5 go on the bottom. So whatever's remaining needs to be split up. And that's how you can kind of work backwards to find the factors if you're given the GCF and the LCM. Okay, so keep that in mind. Now we could also go from here to GCF and LCM. That's a little harder concept to grasp. I find it's easier just to do our regular division like that, okay? Because then you can see the shared factors and you can see the factors that need to be included as well, okay? Easier method. All right. Any questions? Okay. If you look at your homework, I just want to go over your homework real quick. All right. This here is odd letter, so you're going to do 3ACE, then do 4ACE. Okay, you should be able to whip through the first ones. The first ones are just factorizing. Okay, what are the prime factors? So you're just doing your divisions, not even finding GCF or LCM. Okay, get started right away so you have less homework. Okay, hopefully you don't have any if you work hard. Go.